Hi, today in this video we will learn how to conduct a simple linear regression in R. For this we take an inbuilt data set in R with the name faithful. So I'll just invoke that particular data set. Let us have a look of the contents. So I write head of faithful, which will show me the first 6 entries of this data set. So there are two variables here, one with the name eruptions and other with the name waiting. Waiting is the explanatory variable that shows the waiting time or the interval between two consecutive geysers. Geysers are some catastrophic events that occur in USA. So waiting here denotes the interval between two consecutive occurrences of geysers. Now, eruptions. Eruptions is the dependent variable which captures the lifespan of an geyser after it has occurred. So, what I want to do is to find out a simple linear regression model that helps me to understand the relationship between eruptions and the variable waiting. So the first idea is to estimate the simple linear regression, and that can be done in R by the function called LM. So how do I do that? Say eruption.lm is the name of the variable where I'm capturing the result of the linear regression model is equal to LM eruptions regressed on waiting. Eruptions is the dependent variable and waiting is the independent variable, comma, the name of the data set is faithful. So the linear regression model has been fitted and we can look at the result. So the coefficient values which the model has received is intercept is minus 1.8 and the coefficient of the explanatory variable waiting is 0.07. Suppose now, after having fitted the simple linear regression, what we want is to find out the value of the dependent variable given the value of the independent variable. Say I have the value of the variable waiting to be equal to 80 and I want to find out the corresponding value of the variable eruptions from that equation. So how can this be done? We first save the value of the explanatory variable what we want to find out. So suppose I write new data is the variable where I'm trying to store the value of the given explanatory variable. So I write new data and I save it as a data frame as waiting is equal to 80. Say this is the particular value which I have been given. I want to predict the value of the dependent variable eruptions after having fitted this simple linear regression model. So how do I do that? So with the predict function in R, predict eruption.lm, I want to predict the value of eruption.lm given that the value is 80 for waiting. So I write comma new data. So new data invokes the value of 80 for the explanatory variable waiting. That gives me the value 4.17. That means when the value of waiting is equal to 80, the predicted value of the eruptions is 4.17. This is inferred from the fitted linear regression model with the coefficients being minus 1.8 and the waiting time being 0.07 respectively. Okay. Now, let us come to another question. Say for this model, I want to find out the coefficient of determination. Now, coefficient of determination is what? It gives me a fit, a measure of a goodness of fit, of how good the model fitted is actually. So, how do I find that out? I know that the summary of the linear regression fitting contains all the necessary metrics and I can infer it from there. So let us first have a summary measure. I write summary of eruption.lm that gives me a summarized version of the results of the eruption data. Here I have coefficients, I have the residuals and a few important metrics like the residual standard error, the multiple R-square, adjusted R-square and the F statistic along with the p-value. So the objective what I want to find is the R-square value. So I can do that by writing summary eruption.lm dollar r squared. So among these important information, I want to find out the value of r squared. So I quote it with a dollar. I write summary of eruption dollar r squared. That gives me 0.811460. That is approximately 81.14%, which is a significant fit. That is a good fit. All right, so now we know the coefficient of determination for the fitted model. Let us come to the significance test for this linear regression. How do we do that? See, with the coefficients and their p-values, we can find out the test of significance and know whether the explanatory variable is significant in explaining the variations in the dependent variable or not. And what is the idea about it? Okay, so the p-value here, if we notice, for beta naught and beta 1 is less than 0.05. So it is less than 0.05 means that we can reject the null hypothesis that beta is equal to 0. These are the p-values. This is the p-value set for both of them. So as both of these values are less than 0.05, we can reject the hypothesis, the null hypothesis that beta is equal to 0. Hence, there is a significant relationship between the variables in the linear regression model. That means weighting, the explanatory variable weighting, has a significant effect in explaining the variations in the dependent variable named eruptions. So with this, we've been able to conduct a simple linear test of regression. Now let us come to the point if I want to fit a confidence interval for this linear regression. Say the question which I have in hand is that the waiting time is say 80 minutes again, and I want to fit a 95% confidence interval for the mean eruption duration given that the waiting time is 80. So what is a confidence interval? A confidence interval, what it does is, for a given value of x, it finds the interval estimates for the mean value of the dependent variable. Mind you, it is different from a prediction interval, which we'll see shortly. So in the case of a confidence interval, what we do is to find the estimate of the mean value of the dependent variable given the value of the explanatory variable. So say that the explanatory variable value is 80. I want to find out the estimate of, or the confidence interval estimate for the mean value of the dependent variable. And how can this be done? First, I save the value, the given value, in some variable. Say, as I had done before, say new data is equal to data frame weighting is equal to 80. Then I want to predict the value of eruption.lm given this value. So I write is equal to new data, comma, interval is equal to confidence. When I explicitly mention that the interval which I am trying to estimate is a confidence interval, it will give me the confidence interval, the 95% confidence interval estimates. So the result is as follows. See, the fitted value is 4.17 and the lower and the upper bounds, the 95% confidence interval bounds, are 4.10 and 4.24 respectively. That means the 95% confidence interval for the mean value of the dependent variable, given that the waiting time is 80 minutes, is between 4.10 and 4.24. Its estimate has been found to be 4.17. So with this, we've done the confidence interval. Now let us come to the prediction interval for this linear regression. Say again, the question is to find out the prediction interval given a particular value of the explanatory variable. A prediction interval, in contrast to the confidence interval which we just saw, what it does is to find the interval estimate for the dependent variable y for a given value of x. So the difference is to be noted. The prediction interval finds the estimate of the dependent variable y, whereas the confidence interval finds the estimate for the mean of the dependent variable y. So Suppose for the same case again, if I have the waiting time fitted as 80 and I want to find the prediction interval for this, I write the same equation, predict eruption.lm, new data, interval is equal to predict this time. So this gives me the fitted values and the lower and the upper bounds for the predicted interval given that the waiting time is 80. So this means that for the case when the waiting time is 80 minutes, the 95% prediction interval for the eruption, which is the dependent variable, is 4.17, and the lower and the upper bounds are 3.19 and 5.15 respectively. So with this, we've seen a number of things. First, we had a small data set in hand. The first idea was to fit the simple linear regression for it, and given the value of any explanatory variable, we can find the value of the dependent variable from that particular regression fitted model. We've also seen how to find the coefficient of determination at what it means. We've done the test of significance for this linear regression by looking at the p-values and seeing whether it lies, it is more than 0.05 or it is less than 0.05. Then we fitted the confidence interval and also the prediction interval and understood the difference between both of them. So this is how a simple linear regression is fitted in R. Thank you.